Okay, hi. Problem number 6, simplify the expression. I just made a whole video explaining this and I realized there was a typo in the problem. Thank you, AI. All right, so the first thing to notice about this is it doesn't look quite like the problems that we've been doing, the last couple that we did. The last couple that we did looked more like this. And there's lots of things that are different about it, but the one that I really want to point out to you, the difference, is that in this problem, there is nothing between the two quantities. By quantities, I mean what's in between these parentheses. It's just empty. Uh, and when it is empty, we assume it to be multiplication. We assume it to be a multiplication problem. But if there is another operator in between the parentheses, like subtraction or addition or even division, the operator that you see there is what it becomes. So this problem here is not like the ones we've been doing because it's telling us, hey, this is a subtraction problem. This is a subtraction problem. Okay. And what do we do with subtraction problems? Well, we turn them into addition problems at this level of algebra. And I'll tell you why it's really important, because to add these two things, and we could add those two things. This is a combining like terms problem, and we'll get that. But the first thing I want to do is to get rid of these parentheses. I don't like them. And I'm going to tell you, the first parentheses here don't do anything. They don't do anything. So I can take them away. If this had been an addition sign, that would also apply to the second set of parentheses. They don't do anything. I could have taken them away too. But sometimes mathematicians will use them to group certain terms together. And what do I mean by terms? 6x to the fourth power is a term. 7x is a term. 5x to the third power is a term. These things that are separated by the addition signs, I'm going to call them terms. I keep doing that. Okay. So how do I get rid of this? That second set of parentheses? I'm going to tell you. We are going to think of this as not subtraction, but as a, hey, I'm going to add the opposite number. I'm going to add the opposite number. But isn't that crazy that I would just throw a negative up there? Well, it is. But here's what's going to make it a little easier for you. I'm going to assume that there's a 1 in front of this parentheses. Well, can I do that? Sure, I can. X or A or B if I'm playing with these variables, and there's no coefficient, that's the number in front of the variable, I assume there to be a 1 here. This is 1x, this is 1a, this is 1b, even when I don't write it in. Same thing applies to this parentheses, this quantity. It's one of them. So I'm going to write the 1 in because it's going to help me to see that to get rid of this parentheses, I need to multiply this -1 to each of these terms, just like I would distribute any number that was outside the parentheses. All right, so I'm not even going to write in this first set of parentheses because I don't need them. I'm going to take them away right this second. And then I'm going to distribute this -1 inside these parentheses. So what's -1 times a +4? Well, it's a -4x to the fourth power. And what's a -1 times this 2? Well, it's a -2, but there's a subtraction sign here. So just to keep my accounting in order, I'm going to think of this as adding the negative. So now I am multiplying the -1 by a -2. And a negative times a negative is a positive. And then last but not least, I'm going to multiply the -1 by the positive 3x. And I'm going to end up with a -3x. Okay, so now it's combining like terms problem. What's combining like terms? Well, this might be a review or it might not, so I'll take the time to explain it. But with each of these terms, we have a coefficient. I'm just going to pull out the 6x to the fourth. And everything after the coefficient is the number, the first big number that we're multiplying by. We have a letter and we have an exponent. The letter and the exponent, and sometimes there's more of them, but in this case, it's only one letter or one exponent. We refer to this as the variable unit. And I can combine terms that have the exact same variable unit. Notice these are all x's, but they all have a different exponent in front of them. But there's some that are matching. So I want to find the ones that are matching that have the exact same variable unit, and I'm going to add them together. So, because this is like saying 6 oranges, 7 apples, 5 pears. But here's another orange. X to the 4 is orange. I just made that up. Okay, so these two I can add together. I can add the 7x to the negative 3x. They have the same variable unit. And I can add the 5x to the third power to the 2x to the third power because they have the same variable unit. So 6x to the 4 plus a negative 4x to the 4 is 2x to the 4. Oh, look, I could eliminate this answer and I can eliminate this answer. Let's do the third power now. And I bet we're going to come up with 7 because look, there's 3 options for 7. We have 7x, I'm sorry, we have 5x to the third power and 2x to the third power. That's 7x to the third power. So I haven't gotten my final answer yet. I'm still between B and C. But finally, I have 7x and a negative 3x, which gives me a 4x for the final answer of B. How do you like me now? Okay, let's see what else we got.